This presentation is about the WDL to CWL tool for converting WDL files to CWL. A brief introduction of myself. My name is Dennis Chukwunta. I am an outreach intern from Nigeria, and I have been tasked to extend the WDL to CWL converter. In this presentation, I will briefly talk on what the WDL to CWL tool is, show the tool in action, and discuss a little about how the conversion is done. WDL and CWL are both high-level languages for describing workflows. These languages are used to describe how to run and perform tasks in a workflow. A workflow consists of a set of steps connected by inputs and output dependencies. The WDL to CWL tool takes a WDL workflow and produces an equivalent workflow in CWL. And these two workflows are executed with the same inputs. The results produced should be identical. To install the tool, follow the link to visit the project's repository on GitHub. Copy the instructions to your terminal, and it will install the tool and its dependencies in a virtual environment. It's written in Python, so you need to have Python installed. To use the tool, simply type WDL to CWL and point it to the path of the WDL file. If no output path is given, it will return the results to standard out. In this demo, a demo.wdl is converted to demo.cwl. If there are functions or features that are not yet supported by the tool, a warning will be printed to the terminal. These are the two files side by side with their equivalent inputs, outputs, runtime requirements, and commands. Now to talk about how some of this conversion is done. The first version of this converter was by a former outreach intern named Denise. Her work introduced me to the project and taught me some of the features of WDL and CWL, as I had no prior knowledge of the languages. This version also served as a guide for structuring the current version of this tool. In her implementation, she used the Antler parser generator to generate the abstract syntax tree of the WDL file. This worked great for converting simple WDL documents, but when the workflow became complex, achieving a solution was complex and tedious. She created issues and supply tests for the various limitations of the project at the time. This current version handles the complexity of parsing complex WDL documents by using the Python WDL package that comes with the MiniWiddle open source tool. It is a local runner and developer toolkit for running WDL documents. To use, we simply import WDL. To create the resulting CWL document, we use the CWL utils tool, a collection of scripts for parsing CWL documents. The version 1.2 is used in this project. Passing a WDL file path to the WDL load method fuzzies the WDL file and returns an abstract syntax tree document that contains the various sections of the WDL file. This includes the various imports, workflows, tasks, comments, and more. These sections are then handled individually and passed to the CWL utils parser to create a CWL document and returned to a CWL file or standard out. These are some of the WDL objects and their CWL equivalents. This tool does a good job of handling the inputs and output dependencies of the various sections and parts of the WDL workflow. We can't talk about all the various ways these objects are marked, but let's just look into a few instances. CWL graph is used to handle more than one task in a WDL file. If runtime memory is an expression that uses one of the variables from inputs, like in this example here, then a JavaScript ES5 expression is returned for CWL.ground main. This expression calculates the runtime memory in megabytes during execution. Inputs can either be declared or undeclared. The undeclared inputs are known as intermediate declarations, and they are intended as intermediate values rather than inputs. Declared inputs can be optional. In this case, a list of optional type and null is returned for the input. Null allows us to check if an input is optional when the input is called in an expression. Undeclared inputs are handled as CWL expressions. We can return an expression that will evaluate the value of that input whenever the input is required. CWL expressions use ECMAScript 5 syntax. The command can have strings and placeholders. These placeholders can have expressions which could be declarations or functions. When these placeholders are handled, a valid CWL expression is returned as entry in listing under requirements. During execution, a temporary file is created where the output of entry is written to. These are just the quick examples that I can talk about in this presentation. In order to achieve this version of the tool, I had to overcome some obstacles. The biggest obstacle was my limited knowledge about WDL, CWL, JS, and Bash scripting. But thanks to the incredible help from my mentors, I was able to level up and acquire the knowledge needed to accomplish the tasks. Some limitations are listed on the next slide, and a paper will be published in the Journal of Open Source Software documenting the project. Some of the limitations are advanced scatter. These are like scatter objects that call other scatter objects. Some standard library functions and types are yet to be supported. like read map, write JSON, map types, and nested structs. Many of the limitations listed are straightforward to implement, but we haven't needed them yet. If you are unable to translate a particular WDL document, please open an issue and share your example. There are also some tips about using the CWL command line tools, improving outputs, and some other stuff on the GitHub README. They are by my mentor and the coordinator for this project, Michael. My special thanks to Corey, Outreachy, the developers at Miniwidow, and the Common Workflow Lab, and my mentors. Thanks so much for listening, and enjoy the rest of the conference.